Today we are talking about the delegate pattern in Swift. Delegation is a pretty commonly used pattern in Apple's frameworks, but I find that many people have a hard time wrapping their heads around it when they are first learning iOS development. So today we're going to take a look at what delegation is, why we use it, and I'll show you an example of how I use it in my code. It is no wonder that people have a hard time with this pattern. Just take a look at some of the terms that are used to explain it. For instance, this quote from the Swift language guide. This design pattern is implemented by defining a protocol that encapsulates the delegated responsibilities such that a conforming type, known as a delegate, is guaranteed to provide the functionality that has been delegated. That's not particularly beginner-friendly. Or this quote from John Sandell's article on the topic. The core purpose of the delegate pattern is to allow an object to communicate back to its owner in a decoupled way. By not requiring an object to know the concrete type of its owner, we can write code that is much easier to reuse and maintain. Now, if you've been programming for a while, those sentences probably mean something to you. But if you're just starting out, there's a good chance that all that happens is you experience some cognitive overload and you don't really come away from it knowing anything more about what delegation actually is. So let's start with that. What is delegation? The concept itself is fairly simple. It's just one person handing off work to another person who can do that work. Let's illustrate it with a metaphor. Imagine there's an executive. They have some work that they need done and a few questions that they regularly need answers to, but they either can't or won't do those things for themselves. Maybe they don't have time, maybe they don't have the skill, whatever, it doesn't really matter. This person is our delegator. So what the delegator does is write a job description saying, I need someone who knows how to do this task and answer these questions. Eventually, someone will be hired who fits that description. This person is the delegate. The delegate can be anyone in the world, and as long as they sign the contract confirming that they know how to do the task and answer the questions. Then, anytime the delegator needs that task done, or those questions answered, they just hand that off to the delegate who actually does the work and brings the result back. In Swift, we call that job description a protocol. According to the Swift language guide, a protocol defines a blueprint of methods, properties, and other requirements that suit a particular task or piece of functionality. That sounds a lot like a job description to me. When a class adopts a protocol, that is it signing the contract. It is telling me and you and the rest of the code and the compiler and everyone else that it can do everything that is described in that protocol. So if we write our example scenario as code, it might look something like this. First, we have a protocol that defines all the things the manager needs their assistant to do. Then, the manager has an assistant property, but they don't care what class the assistant is, only that they meet the protocol that they've defined for their assistant. Then, whenever the manager needs their assistant tasks accomplished, they just hand that off to the assistant and get the result back. Finally, the assistant adopts the protocol that we've defined, signs the contract, and this won't compile unless the assistant class has functions that match all the signatures defined in the protocol, which this one does, so that'll work. So that explains what delegation is and what it might look like, but it doesn't explain why anyone would want to do it in the first place. Why can't the manager just do the work themselves? Like we said earlier, in the real world, they might be constrained by time or with not enough hours in the day, or constrained by capability, maybe they don't have the skill. Or they might be constrained by desire, they just don't want to do it. And when we're talking about code, this metaphor breaks down a little bit because our code isn't sentient yet, and it doesn't really have any desires. But there are some good reasons why we use delegation, and here are a couple of them. First, it promotes proper separation of concerns. Our manager class can hold all the logic that is necessary for managing and not have to be cluttered up with logic for assisting. It has an assistant for that. This makes our code easier to read and easier to reason about. When you need to update the managing logic, or you're trying to track down an assisting bug, you know right where to look. Second, it decouples our code. That means that each class is not tied to the other directly. We can test each class's logic individually, we can debug them separately, and we can grow one's functionality without affecting the other. And if we want to write a new executive assistant class, we can do that and swap it out for the assistant without affecting anything else about how the manager operates, as long as it has adopted the same protocols. If we work on a team, one person can work on the manager class and another person can work on the assistant class without conflicts. This is what people mean when they say two classes are loosely coupled. Things would be much more tightly coupled if our manager defined its assistant as the assistant class instead of as a manager delegate. Then, any changes to the assistant's interface would also require changes in the manager. In our real-world metaphor, loose coupling would be, I need an assistant who fits this job description. And tight coupling would be something like, I need Dwight as my assistant. No one else works. Finally, it promotes reuse. In the real world, we can theoretically pluck a manager from one position and place them in another. And as long as they know how to manage people in general, it shouldn't matter if they are managing these people or those people. They should continue to thrive either way. The same can be said for an assistant, whether they are assisting this person or that person. And there are many examples of this in code as well. Think about a table view, the kind you see in iOS apps. They're pretty much just vertically scrolling lists of content. But there's a lot of logic used for rendering that table on a screen. You have to manage all the cells, and it would probably be good if you make sure that they're reused so that your app doesn't generate thousands of views for long lists, etc. There's a lot of logic there, and you and I don't want to have to write that every time we need a table in our app. So it would be great if there was a class that we could use to manage that logic. And there is. As it happens, Apple came up with the solution for us, and it is called UI Table View. That class uses Delegation to allow us to define the logic and cell layout for our individual apps while keeping the logic for rendering tables wrapped up in its own class where it can be reused. Now, if those reasons aren't enough for you, I suppose you could write all of your own code without using Delegation. You could use other patterns like target action or callbacks to achieve many of the same things. But if you're developing iOS apps, you're probably going to have to implement at least a few delegates at some point because it's a fairly common pattern in Apple's frameworks, so you may as well get comfortable with it. So how do I use Delegation? I have been developing iOS apps for a few years now, and I have implemented my fair share of UI table view delegates and collection view data sources. But I also like using the delegate pattern with my own views. I tend to lay out my UI in a UI view subclass, define a delegate for that view, and then pass up any events that happen to the delegate. So, for example, if there's a button in the view, the user's action of tapping on that button gets passed to the delegate who actually makes the decision about what to do with that button tap. Usually it looks something like this. First, we define the delegate protocol. This is where we define all the messages our view needs to relay to its delegate. In this example, we're just letting them know that the button has been tapped. But in your production code, you would probably want a more descriptive name for this function. Then we have the view itself. It holds a weak reference to the delegate. The reason why is beyond the scope of this video, but the simple answer is it helps prevent retention cycles. If you want, you can read more about how that works in the Swift language guide. The link is in the description. You may also have noticed that we marked our protocol as being any object. That is because the compiler won't let us mark it as weak in the view if it isn't known to be a reference type, and that is exactly what any object says. You can see that the view itself is pretty dumb, meaning that it doesn't hold really any logic, no business logic at least. It just defines what the UI looks like, and then passes the messages it gets along to its delegate. Then we have the view controller that will hold the view. It has a strong reference to the view, and it is responsible for putting it on screen, although that isn't shown here. At some point, preferably before it is possible for the view to send any messages to its delegate, the view controller has to set the delegate of the view. Here we're setting it to self. It doesn't have to be self, but that's the organization we're going for here. Now, to get that to compile, our view controller must adopt the delegate protocol. Here, I am doing it in an extension. You don't have to do it in an extension, but it is a fairly common pattern that you'll see, and it's a nice way to wrap up all the logic relating to that protocol into one place. It can even be put in a separate file if you want. Regardless of how you conform to it, this is where the logic for what to do when the user actually taps on the button lives. Here, we're just printing a string. This organization leads to all the benefits we discussed earlier. It separates the UI logic from the business logic. So if you have a layout bug, you know that you need to look in the view. It decouples our view from our view controller, allowing you to make changes to the view with no effect on the business logic, and vice versa. And it promotes reuse. Any view controller or even another view could now plug this view in, and all it needs to do is decide how to conform to one new protocol method. And if you do it consistently throughout a code base, anyone can hop into the code and figure out where to look for things with only a few minutes of explanation. So, to wrap up, delegation is just handing off some work from one person to another who is able to do that work. We use delegation to separate concerns, to decouple our classes, and to make our code more reusable. Finally, a good place to start with delegation is between your view and your view controller. I hope that helps you have a better idea of what the delegate pattern is and what it looks like in Swift. And if you have any questions or need help with anything, be sure to let me know in the comments. I'm happy to help if I can. And if you're a more experienced developer and you have opinions about delegation, whether positive or negative, or you have a good example of how delegation can be used, throw that in the comments too, so that other people can learn from your knowledge and experience. Thanks, and I'll see you next time.